So first, let's quickly talk about that phrase, expression. How is that different from something else we've been using all year?
It doesn't have an equal sign.
Good. When you hear expression, we're not looking at equations here. We are not solving equations. We are generally just simplifying expressions. The word simplify goes with expression well. The word solving goes with equation well. Okay, there's no equal signs here. How about the word rational? Rational. What do you think of when you hear that word? Okay. One of our definitions of rational number was a number that had a definite end to it. That works. What's another definition of rational? Because it'll come up in this case.
Reasonable.
Reasonable. So a person that's rational is reasonable. That works too. How about a mathematical definition of a rational number besides a number that has an ending decimal?
Can't you put it in a denominator?
So what's the general phrase for that? Something that has a denominator numerator can be written as a fraction. Anything that can be written as a fraction is a rational number. So when we talk about rational expressions, what do you expect to see if they're rational?
Like they can be, if they're in the simplified form, they're rational.
Yeah, so these are just going to be expressions though, but written as fractions. So we'll have a polynomial over another polynomial. And all this topic is really just factoring again. It's really just factoring. That's all we're kind of doing. So let's jump right into it. So the first thing I want to point out is a common mistake. You cannot cancel things that are not factors. Take a look at this example. The x on top is a factor, but the x on the bottom is not called a factor. What do we call that instead? The x in the denominator there. What do we call that x in the denominator? Instead of a factor, what do I call this x? Where this x is a factor for sure, but this one is not. What do we call these two things that are being added together right here? If they're separated by a plus sign, we use the certain vocab word.
Monomials.
Okay, it could be a monomial, that works. These are monomials, but more generally than just monomial. Each of these are individually monomials, but the whole denominator is a binomial. But what do we call each part of the binomial and not the word monomial? There's another term for it. Called a term, actually. I didn't mean to use that word. These are considered terms. When you use the word like terms, terms are separated by plus or minus signs. Another fancier word that is not really used often anymore are the word addends, two things that are being added together. So when you have a term, you cannot cancel it with a factor. What makes the numerator a factor? What makes the x on top a factor? What's next to it, really? And it's what operation that's applied? Multiplication. There's really a 1 times there. Everybody remembers that a coefficient that doesn't show up is really a 1. So when you see x by itself, it's really 1 times x. And therefore, if I have two things being multiplied by each other, we call those things factors. So you might be saying, well, you know what? In the bottom, sure, there's a 1 times an x also. And 1 and x themselves are factors. Each of these individually are factors. But the entire thing is considered a term. Because that entire thing is separated by a plus sign from the number 2. So simply put, cancel stuff if there's multiplication occurring before the cancellation. So like, for example, if I had this, right? Then I can cancel x's. Because the x in the denominator is being multiplied by 2, which makes it a factor. If x is a factor in both the top and the bottom, I can reduce and leave a 1 behind in both spots because it's a factor. You've seen that before already, but it's really important to recognize this because a lot of students, they go on to take tests that are usually standardized tests and make a lot of common mistakes with this, where they try to cancel things because they look the same. A lot of students see x squared and x squared. Just cancel x squares. But if they're not factors, they cannot be canceled. Again, These are not factors of each other. These are addends or terms with respect to one another. So we cannot cancel them. Okay, it's a common mistake. So let's look at this exactly then. So what we need to do is we need to factor and then cancel the things that are in the top and the bottom. So let's take a look at this first example. A lot of wording here. Okay, we'll talk quickly about this, but this is the formula for what's called electric field intensity. And I thought instead of giving you some arbitrary function, I'd give you an example that has an application. So the equation itself, the equation for the electric field intensity is given by E of t equals F of t over Q. So written as a nice fraction, it's like this. E of t equals F of t over Q. So let's say the problem says the following. We're trying to figure out what is the expression for the electric field intensity if the force function is given as 2t plus 4 and the charge is simply given as 8. The force function is given as 2t plus 4 and the charge is given as 8. So a problem like this, although lengthy in words, is not difficult in that sense because all we're really doing here is plugging in. Again, determine the expression for the electric field intensity. That means determine this right here, E of t. So we're trying to figure out what that value is, or what that expression is. So let's plug in what we know. We know the function for the force function goes here, and the function for Q, or the constant in this case for Q, goes here. So this fraction simply becomes 2t plus 4 over 8. And we're starting with an easy example, as we always do. 2t plus 4 over 8. How can I reduce this? And again, using what we talked about, reduce it. Don't just give me an answer, please, but do what I said in the last part. Make factors. I want to see factors here. I know some of you can reduce pretty quickly, but show me with factoring how this is reduced. Yep.
So 2 is one of the factors, so 2 divided by 8 is 1 over 4.
Give me all the. I want it to broken into factors though. So the top becomes
2 times t plus 4.
no.
Close parentheses.
Somebody help factor 2 out of the numerator more.
Oh, right. T plus 2.
Okay, and the denominator becomes
The denominator becomes 8 still, right?
factor it.
Oh, okay.
I know it's ridiculous to do this. We're starting easy.
You divide everything by 2, so 4.
So when you factor it, it's 2 times 4, right?
Yeah.
So what Morrow is just seeing to cancel is not as obvious all the time with more complicated problems. This is a very simple problem. So he was like, you know what, let's just reduce everything by 2. That's what he started with, which is right. And a lot of you should jump to that for sure. But I want you to see the rationale as to why you can reduce by 2. Why can I reduce by 2 here? Because 2 is a factor. 2 is the greatest common factor of the top and the bottom. So I can cross the 2 off here and here. I leave behind what? What is always left behind when you cross something out? What number?
1.
The number 1. Now, it's not very important right now, but it will come into play. So let's write that for now. So yes, our final answer for this as an expression is t plus 2 over the quantity 4. Again, the 2's cancel. T plus 2 over the quantity 4. It's a mundane, simple, easy example that you guys are like, why are we doing this for? Because in a minute we're going to get to ones that are way more complicated. So recognize that you need to factor out a GCF or something to factor out of the top and bottom that in itself can then cancel, leaving behind what's here. Now, if this is a multiple choice and you're taking an exam and this doesn't show up as a choice, why might that not show up? Or why might that be? What might appear instead? What might appear instead? Come on, how else can I rewrite this? Question.
4t plus 8.
Careful, not 4t plus 8. You're multiplying, aren't you? That would be if the 4 was out in front. Right here, parentheses, and 4t plus 8. I'm not multiplying, what am I doing?
Factor.
No. What is the operation? Divide. So divide this by 4. What's t divided by 4? Can it be written as anything more reduced than that? No. So you leave it as t over 4. But then the 4 in the other part becomes 2 over 4, which is really 1/2. So I want you to recognize that although we're going to come up with answers that can be written in in one way with a monomial in the denominator, the entire thing, if you ever, write yourself a little asterisk on the side, if you ever get a monomial denominator, you can just divide it into everything in the top, into every term of the numerator. When you get a monomial denominator, that monomial, that's the word that Gene used a little while ago, that monomial can be divided into every term of the numerator. I'm not saying it's going to reduce. T divided by 4 doesn't reduce, it's T over 4. So there's no simplification there. But 2 divided by 4 is clearly 1/2. So that simplifies down to 1/2. Either answer is correct. In blue in the box, in red in the box. It doesn't matter. There's another way you could write this answer, technically speaking. How else could I write this on an essay? I'm doing this on purpose, right? So you guys can see that although you think you got the right answer, you might have to manipulate your answer a little bit to look at it in a different form. How else might I write it?
1/4, and then in parentheses t + 2.
Yeah. Well done, Gina. It's another way to write this answer. If you don't agree, go ahead and distribute it. Go ahead and distribute it. This becomes 1/4 t, which is this, and then 1/4 of 2 is 1/2. So any of those three ways is acceptable. Is there any way to write it? And I can technically start going crazy and use like negative exponents. Right? Watch what else I could do. If you remember your negative exponent rule, I could write it like this. Take a look at that. What does a negative exponent mean? It means take whatever is raised to the negative value, move it to the top and make it positive, right? So technically, I would take the t + 2, move it up top and make it to the 1 power, which is exactly this right here. So these are 4 different ways I'm literally writing the exact same expression. God bless you. Okay? 1 over this whole thing is another way to write it. There are literally a ton of different ways. I can write it with multiplication. What I want you to see, though, is to recognize that your choice can be manipulated based on the actual answer you're given. Okay? Or answer choices that you're given, provided it's multiple choice. Yeah? Good? Simple. First example. Second one. Please take the approach I asked you to do, just for now. Again, you know it's easy, but when you get to standardized tests and you're doing it quick, definitely take a quicker approach. Or my test at the end of the chapter, take the quicker approach. But for this problem, please practice using what I told you with factoring. Okay, think about factoring. You write the numerator a couple different ways. You can factor the numerator several different ways. So maybe start with the denominator. Because it looks like the denominator has a GCF, and maybe that'll help us with the numerator actually. Because I could write the numerator how many ways? I could write it as 4 times x times x. I could think of it as 2x times 2x. I can think of it as 2 times 2 times x. But obviously we're seeing that it's just prime factorization that we can do, right, until we get to the lowest amount of factors, which is this, or the smallest factors, I should say. This is the prime factorization of the numerator. So I can use either of those three or any of those three expressions for the numerator. So let me start with the denominator. Maybe that'll help me with the numerator. What can come out of the denominator as a GCF right away, Alex? 2x. Alex, what does that leave you behind with?
3x minus 10.
Okay. I agree with Alex that 2x comes out of the bottom in both terms. Leaving behind 3x minus 10. If that is the case, it makes sense to use which of those three factor forms of the numerator? Yeah, 2x times 2x. It's just logical to do it that way. So when you're thinking about factoring and canceling things, try to think of it in a way where the factors are identical and you can cancel. And that's my result. Okay, I'm left with literally what's here. Yes, I put a 1 here and a 1 here, but 1 times 2x is still 2x. 1 times 3x minus 10 is still 3x minus 10. Sure? Because I was going to ask a follow-up question, maybe it's the same thing you had. Can I reduce this any further? That was the question I was going to ask. I think you were going to ask that. Can I reduce this any further? Yes? How? No? Why not? Yes, with a reason as to why, Or no? Is there a reason as to why not? Can I or can I not reduce this any further? What do you think? Valentina, what do you think?
We can't because if everything is supposed to go 2 or 3, we get a decimal point of 1.5.
So I can see that. That works. That's a great way of outside the box. She's saying, you know what? Take a 2 out of everything. We take a 2 out of here, and take a 2 out of here, it becomes 1.5, and 2 out of here makes us 5. So technically speaking, I could reduce it further with a 2. Anything else? I agree. I wasn't even thinking about that at all. That's a good way to think. We can take a 2 out and just make this 1.5, right? Which is the decimal, which is fine.
I don't know if you're allowed to. Could you like take the 2 out of 10, like the x out of 3?
Okay, so that's the common thing I would see that might not be really true. Let's explain why that is. I'm glad you pointed that out. So Regina recognized that it looks like there's an x here, and the common mistake would be to cancel x's. That's what I was hoping to see. People would say, actually, you can't do that. Why can't I cancel the x's? Alex, what do you think?
Because on the bottom, that's an expression. Or is that's like one term?
This whole thing is a term, right?
Yeah, you can't. If it was just 3x and 2x.
Yeah, if it was like this, like now, like that, then I could cancel the x's. But this whole term and this whole term have individual factors, but I need an entire factor for the denominator, like this 2x was brought outside the denominator, which made it a factor of the whole denominator. While this x is only a factor of 3x, it is not a factor of 10. So I cannot reduce x's because this x cannot be brought out in front. Okay, do not reduce the x's here. And the same goes for the 2 and the 10. Okay? But as Valentina mentioned, I didn't even think about this, you could technically reduce everything by 2. Okay, and to do that, I could simply write this as 2 times x over 2 times 1.5x minus 5. And then I could cancel these 2's, which would give me this answer. Either way I express, at the top or at the bottom, it's the same answer. But that's a great point, okay? You can definitely take it to. Traditionally, just so you're aware, traditionally, most problems don't reduce if it results in a decimal as a coefficient. But again, I talked to you guys about this. Numbers aren't always whole numbers in real life. You'll get decimals, so this is acceptable for sure. Okay? Either of these answers are acceptable. They're both the same. Now, I'm never going to make things bigger. I'm only going to simplify further. So technically speaking, I could double the top and double the bottom and I still get the same answer. I could triple the top and triple the bottom and it's still the same answer. But it wouldn't make sense to make things bigger. Usually you simplify them down further. Okay, but I want you to see that you can do the same thing. All right, let's take a look at one that is a little more complicated than that. We went from a simple one to like an intermediate to like a mid-intermediate, and then we'll get to harder ones in a little bit. So we're told that h of x is given by a polynomial, g of x is given as a polynomial, k of x is defined as h of x over g of x. Determine the function k of x. So let's go ahead and write out its definition. It's defined as h of x over g of x. Here's h of x. And here's g of x. Common mistake, before we even begin, common mistake. Common mistake.
Factor out the x squared.
Yeah, cancel x squareds. It's a mistake though, right? You cannot cancel x squareds. You cannot cancel x squareds. Is that clear? Because they're not what? They're not what? Factors. Very good. X squared itself is a term. X squared is a term on the top and the bottom. It's not a factor. So we can't cancel the x squareds. I will tell you right now that every single standardized test has a problem like this. And what is one of the answer choices? One of them is literally this. Every time. They'll make that an answer choice. And so many students bite right away. They bite for that mistake. They see it and they're like, oh, these drops. Boom, there's my answer. And it's answer choice A or B always. To goad you into doing that. Is that clear what I'm saying? That you cannot cancel x squareds. We must have factors to cancel. So let's create factors. Is there a GCF in the top? Is there a GCF in the numerator? You're seeing no from some and nothing from others. I'm going to go no. I agree. Because nothing can be taken out, removed from all three terms of the numerator. And the same goes for the denominator. There's no GCF. So I can't factor suddenly because there's no GCF. So we go to other factoring techniques. How does the numerator factor? Julia?
Into x plus 4 and x plus 3.
Yeah. So let's just unfoil, right? Or undistribute. They're undistributed. Either way they use that word. Denominator becomes? Okay.
X plus 3 and x minus 1.
And I'm going to purposely put them in this order, if that's all right. Doesn't matter, right, the order, because multiplication is commutative. But I wrote it like this just to be nice, right? Because now I can clearly see, boom, they're gone. How come I can cancel x plus 3's? How come I'm allowed to? They are factors. They are factors, okay? So again, we simply cancel, and there is my answer. Now, the other common mistake as an answer will be giving the answer of -4. Why is that not true? Why would the answer -4 be a common mistake, do you think? What do some students do after this?
They cancel the x's and then have -4 for -4.
Yeah, they do this. They say, oh, now the answer is x. And you know what? The interesting part is this. The minute you write it this way, a lot of students think you can start canceling. Because there's no parentheses anymore, they forget about the concept of factors. But if you have the parentheses on each, it actually reminds you that this entity is a factor, right? X itself is not a factor. X itself is not a factor. X plus 4 is a factor, right? X minus 1 is a factor. I can think of it that way because really, I'm left behind with a 1 here and a 1 here when I canceled those. So technically speaking, I could do this, but it wouldn't make sense to put times 1 in 2 spots, right? So sure, this whole thing is a factor, and this whole thing is a factor, but these factors are not the same, so they cannot be canceled. X cannot be canceled because it is literally not a factor. X is a term. Okay? 2 more. Just to throw you for a loop here. I want you to see any type of way to ask this question. Simplify a rational expression. That doesn't look like a rational expression to me. It does not look like a rational expression to me. Huh?
Since it's the first power of the rational, put 4x squared minus 3x over x squared minus 4.
Very good. So right away, Helen picked up on the fact that it's a negative exponent, so make that exponent positive and just move it down to the denominator. Now, obviously, I'm putting a 1 there just to imply that it's a 1 still. But I do not need this 1 right here. I'm just putting it there for a second. Is everybody clear what I'm saying? I'm going to erase it. That's why I'm saying this. I'm putting the 1 there to indicate that the exponent didn't change. It just changed sign. It became positive 1 instead of negative 1. But I don't have to put a positive 1 exponent because it really has no significance. Let's get rid of it. What do you think we should do? What do you think? Okay, give me some steps.
The first one, you take 4 out of x squared and 36 minus 9.
Good. On the bottom?
You take 2 out of everything.
Agreed? It's a great starting point. Be honest. Be honest. How many of you started factoring the denominator with the AC method right away? Okay, that's good. Very good. Look for the GCF, please, right? A common, not mistake, but a common way to approach this is to use AC method because you see that this is not a 1 value, but because they're all even, let's take out the 2 right away. I agree. So far we're good. I can reduce already, right? I'm going to start by reducing to make life easier. 4 over 2 is really 2 over 1. So let's start with that. I can do that because they're factors, because there's a multiplication symbol here and here. I cannot cancel my x squareds because I don't have factors. X squared and 9 are not factors. X squared and 9 are terms. X squared, x, and 6 are also terms. So what should I do? Mr. Sorrentino, what do you think I should do with the numerator?
The numerator?
The numerator.
Oh, find what's it called? I forgot what it's called.
That's okay. Tell me what it turns into, though.
It's x plus 3x minus 3.
Very good. Difference of 2 squares. Good. The factors. He recognized right away that this is a difference. These are squares. Difference of 2 squares are always factors in x plus and x minus. These, again, we call conjugates of one another. Why did I pick that? Because the numerator, when written as difference of squares, is very easy to factor. and they'll most likely be a repeating factor in the denominator. So when you're taking standardized tests and one of them is more difficult to factor than the other, start with the easier one because there's a good chance that the factors will recur or show up again in the other spot. So I'm probably going to have a 3 in the bottom somewhere. So I know already that there's going to be an x here and an x here. One of these is going to be a 3, either plus or minus, I don't know yet. If one of them is a 3 and I have a 6, the other is most likely going to be a 2, most likely. So let's put a 2 here for now. And what works in this case?
X minus 3 and x plus 2.
Again, because Julia recognized the middle term is -1, these values always add up to the middle term. Okay? Cancel your x minus 3 with your other x minus 3, giving us a final answer of 2 times the quantity x plus 3 over x plus 2. Another time that is very simple or very easy to make a mistake. Everybody wants to always simplify completely. They're like, oh, I gotta keep going. No, this is done. Don't reduce your 2's. Okay, I've seen the 2's reduced in a problem like this because it's a factor here. So you think, oh, it's a factor, I can cancel. But this is not a factor in the denominator anymore. Okay, so I cannot cancel that. So leave it the way it is. Again, I can write this many different ways. I could write the same expression as 2x plus 6 over x plus 2. Either of these two are acceptable. All I did was distribute the 2 into the numerator and give you a separate way of looking at it. But in either case, it cannot be simplified further. Here, write yourself a note. Write yourself a note, please. Whenever the denominator has more than one term, so not a monomial, we did a monomial earlier with our note. Whenever the denominator has more than one term, you have to factor further to reduce. Whenever the denominator has more than one term in it, like this, you have to factor further to reduce. So if you could take anything else out of it, then you could reduce, but you cannot in this case. But you can't just divide this into both terms. You could try, it would work technically, like this. Well, this is what it would turn into, but it's just messy. You could write it as 2x over x plus 2 plus 6 over x plus 2. You could do that, that's okay. I could take the whole denominator and divide it into every term of the numerator, that's fine. But these don't reduce, and these don't reduce. So this doesn't really help me anywhere, right? It doesn't really make sense to divide the denominator into both terms of the numerator because they cannot reduce any further. So writing it this way doesn't make any sense. Aren't these common denominators? Right? When you have common denominators, you would simply write it as one denominator, which is this. And then you would add the numerators. So you get back to here anyway. Okay, so when you have a denominator like this in multiple terms, it's not very useful to divide it into every term of the numerator. It was useful when we had a monomial. When we had an 8 right here, we took the 8 and divided it into both of these, and it was able to reduce. But when it's a binomial, you really need to factor further to start reducing. It doesn't make sense to do this. Okay? So I would just put a big, it wouldn't really be doing that. It's not logical because it's a binomial or more in the denominator. Binomial, trinomial, anything beyond that, polynomial in general, is not useful to work with this way. When it's a monomial in the denominator, then it's useful to divide it into all the terms. Only when it's a monomial is that useful. Let's try the last one. Okay, I just made this harder. That's all I did. It's no more difficult than the last one as far as technique. It's just about your factoring skills now. Are your factoring skills up to par? Is really what this question is asking. Spend about 2 minutes. Try to factor, please. About 2 minutes. If you're struggling with the denominator, it's much harder to factor. Start with the numerator. It will help you to think about what goes in the denominator. The denominator is definitely a C method, unless you can do it by looking, which you might be able to if you factor the numerator properly. Alex, what's the numerator going to factor into? It's not obvious, but it's there. Can somebody help me out? Don't give me the answer, but help Alex out. What kind of factoring is this an example of in the numerator? What technique did we just use a little while ago?
Difference of 2 squares.
Go ahead. So what do you think, Alex? What should it become?
Wait.
If it were?
I remember what it is. I just kind of.
If it were this, remember it becomes x plus 3 and x minus 3. Use that as your schematic. What should the numerator become? Think about where the 3's came from, and think about what you should get as a result instead now. The 3's came from the square root of this, right?
Yeah.
So what am I going to put? What's the square root of this guy over here now?
Oh,
So let's put a 6 here and here. The x, right, came from the square root of this, didn't it? So what am I going to put?
5x.
Very good. It's always going to be plus minus, okay? So we need to recognize that although this looks difficult, it is dots, difference of 2 squares. Here's my numerator. Why did I say that? Because if you're going to have reduction, you have to have cancellation, right? So there's a chance that one of these factors will appear again. So most likely we're going to have a 5x and a 6 somewhere. One will be a minus, one will be a plus. Now, let me give you a little trick. For those of you that don't want to deal with AC method, if you know that 5x is going to be here, what must this binomial start with? If I write out my other one, Francisco, it's got to be 2x. Because 5x times 2x gives me the 10x in the front. Let me put that parentheses better. There we go. 5x times 2x gives me the 10x squared right in the front in that denominator. So you know that already. Now, Francisco, to follow up, because you answered the first part, if this is a 6, Francisco, what must this be? 3. Again, do the math, guys. If this is a 6 and this is a 3, 6 by 3 gives you 18. So you know that that's going to be 3 right there. So you kind of have this already. What do you have to now figure out? Signs. Is it a plus, is it a minus? Look at the middle term. The middle term is positive, isn't it? So we're most likely going to have a bigger value that is positive. So let me try positive, negative, and a negative, positive. I know they're going to be opposites because this last answer is negative 18 here. So this is going to be the opposite of the other one. So one's positive, one's negative. It's a question of which is which. At this point, it's trial and error. If I make this positive, this becomes 12x. When I multiply, this becomes negative 15x. Negative 15 outweighs a positive 12, which would make the middle negative. So it doesn't make sense to call this positive and call that negative. So if it doesn't work, we just flip-flop. Make this a negative, make this a positive. And now if you FOIL it, you will get exactly what we have. This will give you a negative 12x when you multiply the inner terms. And then when you multiply the outer terms, you'll get 15x. 15x plus negative 12x gives you 3x. Negative 6 times 3 gives you negative 18. 5x times 2x, then x squared, we're good to go. So I did this without AC method. Does that make sense what I'm saying? Is that clear what I'm getting at? Use the other part to help you factor. And then you might not even need AC method if you just work with your numbers a little bit.
Wait, I don't get why you got like minus 6 and plus 3. That would be
Because when you FOIL, what do you have to do? First is multiplying these. Outer means multiply these. That gives me 15x, right? Inner means to multiply these guys right here, which gives you negative 12x. When I add 15x and negative 12x, I have to get 3x at the top.
Could it be like, could it be either way, or does it have
Well, then it would be, sure, but then it would be a negative up here where it should say positive, right? So had this been a negative 3x right here, then this would have been positive, this would have been negative, which would switch these two signs, which would make the negative bigger than the positive, which would yield the negative overall sum. See what I'm saying? Okay, so by changing these two signs, you would be changing this. Because if I make this a negative now it's negative 3 times 5x, which makes that negative 15x. Making that positive is positive 6 times 2, which would be positive 12. So these signs would switch, which would switch this sign over here. Okay? So just simplify at this point. Reduce, reduce, reduce. 5x minus 6 cancels in both spots, giving us a final answer here of 5, oops, let's do that better, of 5x plus 6 over 2x plus 3. Okay, again, be careful of common errors. Don't reduce this, please. Please don't make this 2 over 1. It's just one of those things. Students see 6 over 3 somewhere, and they think right away it's 2. But these are plus signs, so these are addends. You can't cancel addends. You can only reduce factors. Questions overall about this topic? Tomorrow's lesson is very similar, but a little trickier, because we start using operations of multiplication and division. But it's the same concept applied. Okay. Awesome. A little bit earlier, which gives you a little bit of time. Feel free to either A, start this, or B, if you want to ask me a question about your project. You work that on Friday, you're going to come over individually, you'll look at your project. We have 7 minutes or so. Okay, so if you want to start on it, I'll come by, I'll start with Julie, and then come over to Christian next.
I filled in all my tables, so I just have to find out cost.
Okay.
How do you do that?
We'll go back here, top up here, what's your cost per item?
That.
Where did those come from? Did you make those up?
I think it was in the. Was it in the?
Open the document, you have it. Did you put those up? No. Let's just play an example.
Oh, it's in my drawer.
Did you draw it? So did you pull those right from there?
Yeah.
Okay. So as long as they're right, let's go back to it. So it takes 40 cents, it costs 40 cents to store a bike. How many bikes did you store in period 1? What's your table for bikes? In period 1, how many did you have stored? 20. And it's 40 cents a bike, right? $8, right? But did you store any more bikes in period 2?
No.
3, 4, 5, 6, 7, 8, right? So total, you're going to have 20 cents times, 40 cents times 20 bikes.
Oh.
Now, that's for bikes.
It's $8.
Correct.
So I just write that here.
And you can use Excel to do the formula for equals. Equals, right? Equals this cell times, this cell, this cell times that cell right there. Times that cell right there. So just write a formula to do it. But now for the next one, what do you notice is different?
I store more.
You store 10 handlebars in the first
Does
period.
this count?
No, that's always coming in from the previous quarter.
What happens if I have extra at the end? Because there was like 1 or 2 where I had extra at the end.
Storage. You have to count storage each period. So 10 stored in the first period. How much does it cost to store? 10 cents? That's $1, right?
Yeah.
How many are stored during period 2?
35.
It's $3.50.
35 again in period 3, and that's it.
Is it 35 again or 25 again?
35. I think.
So, yeah, that's fine. I just thought I switched it one time. So $3.50, $3.50, and $1 gives you a total of another $8 actually. That's coincidence. Okay? But you can use a formula and you could say equals, right, this cell, which is the cost per storage, right, times the sum of that entire row. In your row, if I recall, it was 10, 35, 35, 0, 0, 0, 0, like that. So I could just do that instead, because this is 0.1, and I'll put a 0.1 here, and then I'll just add these together. This will give me 70, another 10 is 80. The sum of all those cells, whatever they are, will be 0.1 times 80, or simply $8. Instead of calculating the cost of this one, plus the cost of this one, plus the cost of this one, just find the sum of inventory that you're holding, which is 80 items, times the cost per item per period, to give you the total cost. Okay? That'll help, I think. Christian was next. I'll come by next to you. No, your summary, honestly, is really just give you the total cost and those last rows. As long as the last rows are right, that's all you have to really focus on. The plan over releases at the end. You work your hands on those rows.
Chapter 5 is like the Google.
Is that in there?
Yeah.
Chapter 5, okay, I'll put that in a second.
I think I accidentally messed with my corporate folder because now I can't edit it, so I can't put stuff in it, right? I think you edit because you're the owner. Because I was trying to
quick?